Find the remaining trigonometric functions of theta given that cotangent of theta is 1 over 4 and sine of theta is negative. First, since sine of theta is negative, theta has to be an angle in the third and the fourth quadrant. We will use the right triangle to obtain all of the necessary information for the remaining 5 trigonometric functions. As of now, with sine of theta being negative, we narrow down theta to be in the third and the fourth quadrant. We still need to get rid of one quadrant. Cotangent of theta is the reciprocal of tangent of theta, but if cotangent of theta is positive 1/4, then tangent of theta has to be positive 4 over 1. But tangent of theta is positive in the first and the third quadrant only. The intersection is the third quadrant, telling us that theta is an angle in the third quadrant. Armed with this, we will draw the triangle in the third quadrant. A generic right triangle in the third quadrant has one of the legs coincides with the horizontal axis. In the third quadrant, x is negative and y is negative. This is x comma y, where x is negative and y is negative. Since cotangent of theta is 1 over 4, tangent of theta is 4 over 1, but tangent of theta is y over x. We cannot make y equal 4 and x equals 1 in this case because in the third quadrant, y is negative and x is negative. This is a quick fix because 4 over 1 is the same as negative 4 over negative 1. And so we would make y equals negative 4 and x equals negative 1. If y equals negative 4 and x equals negative 1, using the Pythagorean theorem, we have x squared plus y squared equals the hypotenuse squared. Y is 4 and x is 1. 1 squared plus 4 squared equals r squared. This is 1 plus 16, r squared. R equals the square root of 17. Armed with the hypotenuse and the two legs, we are now in the position to write the 5 remaining trigonometric functions. Sine of theta is opposite over hypotenuse, which is y over r. But y is negative 4 and r is the square root of 17. Cosine of theta is x over r. X is negative 1 and r is the square root of 17. Tangent of theta is y over x, which is negative 4 over negative 1, which is the reciprocal of cotangent, as it should be. Cosecant of theta is the reciprocal of sine of theta, which is the square root of 17 over negative 4. Secant of theta is the reciprocal of cosine of theta, which is the square root of 17 over negative 1. And cotangent of theta is negative 1 over negative 4, but this is given. Lastly, we will need to simplify these expressions by rationalizing the denominator. Negative 4 over root 17 is negative 4 root 17 over 17. Negative 1 over root 17 is negative 1 root 17 over 17, or simply negative the square root of 17 over 17. Negative 4 over negative 1 is 4. Root 17 over negative 4 is negative root 17 over 4. we usually don't write the negative in the denominator. The square root of 17 over negative 1 is simply the square root of 17. And 1 over 4 is simply 1 over 4 already. In this case, we determined the sign of x and y before we found the trigonometric functions. Alternatively, we can just simply pretend that y and x are positive, and then after we obtain the ratios, we can put in the sign. If the angle is in the third quadrant, then sine needs to be negative, cosine needs to be negative, tangent is positive, and the sign of their reciprocals are corresponding to the sign of sine, cosine, and tangent.